Welcome back to Critidas Math. Today we're going to be looking at a few more Pythagoras type questions and also looking at how to deal with isosceles triangles when using Pythagoras. So for question number 1, we have find the length of side AB for each triangle. So question 1, well 1A, is a simple problem. So it's your standard Pythagoras. So first of all, we have to remember what our formula is for Pythagoras. We've got a squared plus b squared equals c squared. And we need to remember that labeling the triangle is one of the most important steps in Pythagoras. So we want to make sure that we're labeling side C correctly. So C is either the longest side of your triangle, you can find it that way. If your triangle is a little bit ambiguous on which side is the longest side, you can always use your right angle as a reference point. So your hypotenuse, your side C, is always on the opposite side of your right angle. So your right angle is looking over at it like this. So that means this side here, which is 3, that's going to be your side C. And then this side over here, we can label it as A or B. It doesn't matter. A or B are interchangeable since they do end up getting added. Okay, so now we're going to substitute all of the values that we have. Our A is 1.5, so we're replacing A with that, squaring it, plus B squared we don't know, so we leave B there, and C is 3, so 3 squared. And now we'll do our math. So 1.5 squared, that gives us 2.25 plus B squared equals 3 squared, which is 9. Now we want to isolate for that B, so we need to use our algebra. We're going to have to move this over. So to get rid of this 2.25, we need to subtract. We're going to subtract 2.25 from each side. We get our B squared equals 6.75. And now 6.75, that's the value of B squared. We don't want B squared, we want just a length of B. So to get rid of that square, we need to square root it. So when we get square root that, we get B equals 2.6, just about 2.6. It's 2.598, blah, blah, blah. So about 2.6. Okay, so that was 1A. Now this one over here is a little bit more challenging because you have an isosceles triangle. So these two little lines here are telling you that these two sides are equal. So we're going to start off with our formula again. A squared plus B squared equals C squared. And since our right angle is here, looking over there, our 13.5, that has to be our C. So now we can label these sides A and B. But we do notice something special about A and B, and that's that they are exactly the same. So because they are exactly the same, we can say that A equals B. They're the same thing. So I can choose to actually label these using the exact same letter because I know that this B is the same as whatever this A is. So instead of B, I'm just going to scribble it out. I'll scribble it out a little bit and replace it with A because I know that this B is going to have the same value as this A. So now when I use my formula here, instead of putting in A squared and B squared, since I know that B is going to be the exact same number as A, where I have B in my formula, I can now replace it with A instead. So we can rewrite our formula as A squared plus A squared equals C squared. Since we know that these two numbers are going to be the exact same number, we can use the same variable to represent them. So now all of this can be simplified. And if we think back to our exponent rules, if we have 1a squared plus 1a squared, Since there is an invisible 1 in front of both of these, the coefficient there is 1. 1a squared plus 1a squared. We have 2a squared on this side equals, and c is a value that we know. It's 13.5. So we're going to put in 13.5 on this side, and that's going to be squared. So here we're just going to drop this down. That's fine. Rewrite it. Have our 13.5 squared. That gives us 182.25. And now we need to isolate for this a. So we've got a few things going on here. We have a multiplication and we have an exponent. So something that's useful to remember is when we are doing algebra. So normally when we have an order of a chain of operations, a big problem involving a lot of steps, a lot of operations, we usually use BEDMAS, right? So BEDMAS is when you're going forwards, when you know all of the numbers in your operation. If I had this number a, if I had it, I would start by squaring it because exponents come first, and then I would multiply that result by 2 because multiplication comes after exponents. But when we're doing algebra and we're solving for a, we're going backwards. We're going against BEDMAS. So this is a little thing that you can use to help you stay on track when you're doing your algebra, is identify what operations do we actually have here. We have a multiplication and we have an exponent. So I have to undo that multiplication and exponent in the reverse order of BEDMAS. I'm going backwards. This is kind of like unwrapping a present. When you get a present for someone, you put it in a box, you tape up the box, and then you wrap it in paper, and then you put on the bow. But when you unwrap the present, which is when you're doing algebra, you do it backwards. You take the bow off, then you unwrap it, and then you open the box. So you have to go against BEDMAS when you're solving. So when we go backwards here, we notice that we hit multiplication first, which means I have to undo this multiplication. The 2 times the a squared. Since my goal is to be left with a squared, I have to get rid of this piece. So to undo a times 2, I have to divide by 2. So I'm going to divide everything by 2. A squared equals 91.125. And now I've done the multiplication part, I'm left with the exponent part. And I can undo the squaring by square rooting. When I square root, I'm left with a equals approximately 9.55. So both of these sides are equal to 9.55. Okay, so that was 1b. Now we're on to this question number 2. How wide is this circle? So here's our circle. It's inside a square. And you are being told that the measurement of DE, that's this diagonal line right here, is equal to 18 centimeters. So now we need to figure out, well, what is the widest part of the circle? The widest part of the circle is right down in the middle here. Right, so it's the diameter of the circle. There we go, if that's the middle. And what does this line here line up with? Because the only thing that I have a measurement of is in relation to my square. It's not in relation to the circle. So I need to use the square if I'm going to be able to use this side. So I need to figure out, well, what part of the square lines up with this diameter. So feel free to pause the video at this point if you kind of want to puzzle this out and see if you can figure it out. And now if you've unpaused it, if you decided to pause it, I will show you how to do this. So this line, if I kind of just drag this up and down, right? I notice that the diameter of the circle lines up exactly with the side of the square. So to answer the question of how wide is the circle, I can also ask, well, what is the length? What is the length of the side of the square? The answer to this question is the same answer to this question because the diameter of that circle is the same as the length of the side of that square. So now that I know I'm looking for the side of the square, and since all the sides are the same, I see something happening here. There is a triangle that I can pull out of this entire problem. So if I pull this triangle out, make a triangle. Oh no. Oh, it's giving me an arrow. Okay. We'll just settle for that. So if I pull out the triangle, I know that these two sides are the same, and I know that this length here is 18, and that this 18 has to be C because the right angle is looking over at it. And since these two sides are the same, I can do the same thing I did before, and I can label both of these as A. And we know that if we kind of just look up here at what we did in this example, that it'll end up simplifying to this same thing, this 2a squared. So I'm going to write it like that, just 2a squared equals c squared. And this is a formula that you can use when you have an isosceles right triangle. So we're looking for that a again. So 2a squared equals 18 squared. So we're going to do exactly the same steps as before. 18 squared, we get 324 equals 2a squared. So again, we're using our BEDMAS backwards. We're dividing by 2. And I'm just going to move all this up a little. We get a squared equals 162. And again, we will have to square root. And a equals just about 12.73. So that's number 2. Over here we have what is the area of this triangle. So when we do area of a triangle, so remember that the formula is base times height divided by 2. So here we have an equilateral triangle, which means that we know that all of these sides are going to be 15. So we know the base. We have the base of the triangle. We're good with that. We do not have the height of the triangle. The height of the triangle is going to be right here, and it's going to cross at a right angle. So that is going to be something that we need to find. We need to start by finding the height of the triangle. And to do that, we need to pull out a little right angle triangle here. So this guy right here is going to come out. I'll draw it over here. Now I got a little triangle. We know that this is 15. This is what we're looking for. And this is where you need to be careful when you're cutting up your triangles like this, is that this over here is not going to be 15. It's going to be half of this 15. So 15 divided by 2, this is going to be 7.5. So now we need to label our sides again. So from that right angle, looking over, 15 is going to be C. The other sides are going to be A and B. So an A squared plus B squared equals C squared. We've got 7.5 squared equals 15 squared. So A squared plus 56.25 equals 225. We can subtract that 56.25. And we get A squared equals 168.75. And as usual, we will square root to get our final answer. So we get A equals 12.99, very close to 13, but not quite. And now we finally have our height. So we can now find the area of our triangle. So we have 15 times 12.99 divided by 2. We get 43 centimeters squared. Okay, so I've got 2 more questions for you. So this is just an example of how you can see Pythagoras represented when you're doing solids. So here you have a cone. So the cone's given to you, and you're being asked to calculate the height. So you're being given the apothem, which is this angled side, the slanted side of the cone, and you're being given the diameter of the circular base. So whenever you're asked to do this, you need to use Pythagoras, and you have to identify the right angle triangle and pull that triangle out of the solid. So that is not a right angle triangle. So here we're being told that this is 17 and that the diameter of the entire circle is 16, which means that the diameter here, well, the base of this triangle is going to be 8. So we have to do that 16 divided by 2. And now we can use our Pythagoras without any issues. So it's just standard label our triangle. So across from the right angle, we have 17. That is C. This is A and B. And you solve as usual. So A squared plus squared equals 17 squared. 289. And then we isolate. So we get A squared equals 225. And you should do a little bit of mental math here. Square root of 225 is 15. So that's our height. Okay, and then the last question is Pythagoras, but the converse, which means we've been told that a triangle, so if we have a triangle with a right angle, then A squared plus B squared equals C squared. This is kind of the logic that we've been using. If we have a right angle triangle, then this is true. So now we're using what's called a converse in math. It's just the reverse logical order. We're going to say if A squared plus B squared equals C squared, if that is true, then the triangle is a right angle triangle. So it's just the reverse logic. So here we're being given the numbers, and we have to show that there is a right angle in here. So, or if there is a right angle. So state if the triangle is a right angle. So it could not be. So what we're going to do is put in our formula as we normally do. And now since we don't have a right angle to go off of in here, what we have to do is essentially use the biggest number as C. Because if this is going to be a right angle triangle, then the biggest number would have to be C. So this has to be C, and then these ones can be A or B, it doesn't matter. So we're going to put those in here. 8 squared plus 6 squared equals 13 squared. So we get 64 plus 36 equals 169, and 64 plus 36 gives us 100. And this is not true. So you can put the very mathy, this is the most satisfying symbol to use in math, this little lightning bolt. That means contradiction, which is basically saying like this makes no sense. This is not true. So we can say the triangle is not a right triangle. The triangle is not a right triangle. It's some other kind of triangle. Okay, so that wraps up our final video on Pythagoras. And if this video helped you, make sure to hit that like button. And if you'd like to be notified of future videos, make sure to subscribe and hit the little bell. I will see you in the next one.